Hi class, today's lesson is lesson 7-5. Let's take a look at the purpose. Our purpose today is to use proportions and similar figures to find unknown measures. Now what I mean by similar figures are essentially polygons or multi-sided figures. We're going to use that and our knowledge of proportions to find the unknown measurements or lengths of sides today. We have one vocabulary term. It's indirect measurement. Indirect measurement. Kind of lengthy, but necessary. Indirect measurement is using similar figures and proportions to find a measure that would otherwise be hard to measure directly. In the examples that we're going to be using, we're going to be using shadows in order to, the length of shadows, in order to figure out the length of a building, the length of a flagpole, those sorts of items that we can't, take a tape measure and actually run up the pole and measure. We're going to do that through indirect measurement. Let's take a look at our first example. It's of the Statue of Liberty. Here it says, both the person and the statue form 90-degree angles. So 90-degree angles are right here. And that's the sign of a 90-degree angle. It's a little square in the corner of this triangular shape. Both the person and the statue form 90-degree angles with the ground, and their shadows are cast at the same angle. This means we can form two similar triangles and use proportions to find the missing height. In other words, this right here forms similar triangles. And boy, that is really ugly in outline because it doesn't look similar in that way. But you can see that the triangles are roughly similar. In fact, they are similar in real life. Use the similar triangles above to find the height of the Statue of Liberty. So now we're going to be comparing the actual length of this man and the length of his shadow to the length of the shadow of the Statue of Liberty to determine what this actual length is. So let's go ahead and start. We're going to go ahead and compare corresponding sides, 6 to whatever this will be. We're going to call it, well, let's call it H. Okay, so it's going to be 6 to H, that's one ratio, is equivalent to 12 to 610, these corresponding sides, 12 to 610. Notice that we have the measurements on top are of the man. The measurements below are of the corresponding lengths with regard to this statue. Now we just go ahead and cross multiply. 12n equals 6 times 610. We're going to go ahead and off to the side now. We're going to multiply 6 times 610. That's 0, 6, 36. So now we have 12n equals 3,660. In order to isolate the variable and solve the problem, we're going to divide both sides by 12. Where now n equals 3,660 divided by 12. Goes in 3 times here. Zero times here. And 5 times here. 5 times 12 is 60. No remainder. Our answer is 305 feet. Let's go ahead and reveal the answer here. The actual height is 305 feet. Let's go to the next example. It's very similar. This time we have a meter stick and a lighthouse. A lighthouse casts a shadow that is 36 meters long, and a meter stick that casts a shadow that is 3 meters long. So here we have a meter stick casting a shadow that's 3 meters long, and the lighthouse casting one that is 36 meters long. How tall is the lighthouse? Once again, we're going to go ahead and make a ratio of the corresponding sides because these are similar triangles. Although one triangle is within the other, it doesn't matter. They are similar. So we take the height of the meter stick, which is 1 essentially. Compare it to the height of the lighthouse, which is h. Once again, we go back to the meter stick for the next ratio because order is important. So we went from meter stick to lighthouse. Now we're going to go back to meter stick to lighthouse. In this case, we're doing the shadow of the meter stick, which is 3. The shadow of the lighthouse, which is 36. We're going to go ahead and do cross products. Notice that the cross products crosses right over an equal sign, which means we are doing authentic cross product. We have 3h on this side. We have 36 on this side. Isolating the variable, we're going to divide by 3. 3's drop down on that side, leaving us with just the h. 36 divided by 3 is 12. What does that mean? Well, it means we have a lighthouse that is 12 meters in height. Now it's your turn. You're going to use the similar triangles to find the height of this lamppost. Here we have a 6-foot post, and here we have a lamppost which we don't know the measure of. We're going to use indirect measurement using proportions, using ratios, in order to find out what the height of the lamppost is. And if you're wondering what this is, this is the beginning of setting up my ratio. In fact, we'll do the first one. My height of 6 here is going to be the top. 6 is to h. And you're going to go ahead and finish or complete the problem. See you in class.